Well, hello there, and glad to have your company as we begin this important series of electricals tutorials for the AirSim3D C560XL aircraft. We've already covered several topics about main battery access and starting engines that have main and emergency battery connections. And as mentioned in other tutorials, each one builds on knowledge gained in previous ones. So please view our tutorials in their numbered order so we don't have to constantly provide context or repeat things and bore you in later tutorials. So in this tutorial, we focus on the main battery operations and talk about where to find the different batteries, what they are used for, and how they are managed and charged. We'll also talk about things that can abuse the batteries to cause dangerous over temperatures. And separately in a later tutorial, we'll cover the battery charging system operations when using the highly customized APU and GPU. So that's upcoming. So to begin, the aircraft is built with two batteries, a main battery and an emergency battery. The main battery is the first thing a pilot turns on when starting a flight, and the last thing that is disconnected after a flight. We cover how to access the battery compartment outside. To do this in both XP11 and XP12 in the exit and panels tutorial, and yes, there is a difference on how to open and access the main battery compartment depending on which sim is being flown. So please watch that tutorial for more detail. Each tutorial builds on the next, so we're not going to repeat all that content here again. As I mentioned earlier, the second battery is the emergency battery, and like its real-world counterpart, the emergency battery cannot be accessed during normal flight operations, and that is the way Cessna designed it. In XP12, the emergency battery also powers the checklists in the cold and dark starting state. In XP11, pilots need to power the MFD to get access to the checklists, and all this is covered in earlier tutorials anyway. But in both XP11 and XP12, moving this battery switch to emergency cuts back on power consumption and therefore provides a limited set of critical backup flight instruments, which are the standby HSI and VOR, checklists from the norm button on the MFD, the left side engine instruments only, and on the far right, the fully functional standby common nav radio. Below it, the gear position lights display gear status. Now, of the two clocks on either side, only the pilot side works, but notice below that the comm panel on both the pilot and co-pilot sides function. And finally, the DC voltmeter in the lower left on the pilot side. Although if you notice, it now has a small LED to light up and conserve power, and it's not backlighted as it would be if the panel were operating under main battery power. There's a little attention to detail there. So as you can see, the C560XL panel in this state is very realistically lighted. There are no fake 2D lit textures, only real 3D lighting that's tuned, directed, and colored for a spectacular night flying, authentic experience, which we feel is a real differentiator in this aircraft. We discuss instrument details in this panel in the next tutorial. Yeah, try flying this panel at night in bad weather. It can be a real challenge. One last thing, in this emergency battery state, the autopilot also continues to function, but since the main PFD and the AP status bar is not available, it's not recommended that the AP be used when operating under emergency power.
50, 40, 30, 20, 10.
Moving now to main battery functionality, and assuming that it is connected as we discussed in earlier tutorials, then the switch on begins to power up the jet's cockpit. The electrical system also includes a voltmeter and two engine amps that display main battery charging rates. They are not battery amp gauges. You'll notice another amp meter on the co-pilot side, and that one is for the APU amperage only when it is running, but we'll talk more about that later. So critically important to remember when interacting with the outside main battery and its main switch on the front panel. The main battery will not power the aircraft if either of these two conditions exist. First, the battery disconnect switch under this red cover is off. Generally, it is kept on at all times unless the pilot needs to isolate the main battery from the rest of the aircraft. It is not a battery on and off switch. In real life, this isolation function is mainly used 99% of the time by ground crews during routine battery maintenance. So there's no real cause to use it at any time for the pilot unless there's an emergency. But that's something to check to see if you see a dead panel. Check to see what that switch position is. Next, and this one is important as it can cause frustration for pilots who have just jumped in and are flipping things around. So please do not do that without first starting the aircraft. Please don't do that. So if the battery switch is in the emergency position with the engines running, and if either of the engine generator switches are on, then if the battery switch is then turned up to the main battery position, the pilot will continue to see emergency instruments only. This is not a bug, but it's authentically designed to prevent damaging the main batteries. So how do you correct and fix this? First step, switch the main battery to the off, the middle position. Then turn both engine generator switches to off. Next step is to then turn the battery switch back up to the on position, and then all will be well. And just to repeat, since this is very critical to battery health, if at any time you have generators on and the battery switch is moved to the emergency position, you cannot simply turn the battery switch back on and expect the cockpit to light up again. You must go through the 3 steps we just outlined to get back to a fully lighted cockpit. So returning to the 2 conditions when the battery will not provide adequate power to the aircraft, the second condition is this. Unlike what you might be used to doing in other aircrafts, that is to start the APU first for engine starts, that is not always necessary in this jet. Wonder of wonders, this aircraft can be started using the main battery power only. But, there's always a but, right? And this is the important part. But only if you see the voltmeter displaying more than 22 volts. We've covered engine starts extensively in past tutorials, but critically for this tutorial, to initiate a battery start, a pilot needs to see the voltmeter displaying more than 22 volts. So if trying a battery start and the engine spins and will not run when fuel is introduced, check to see if the battery has enough voltage for the battery start to begin with. If it's low, the APU will need to be used to help spin the engine's turnover fast enough to be able to start them. And going one step back further to the more overarching electrical side of things, once an engine is running and stable, only then should you turn the engine's generator switch on and watch the amp meter. If the battery is low, the charging rate from that single operating generator will be quite high. If you started both engines and both generators are off and the battery is kind of depleted, then in that case, it is advisable, although not mandatory, to turn one generator on only and watch and wait until the charging rate observed in the amp meter is under the red hash, and then to bring the other engine generator online. You can start the other engine but keep its generator offline until the charging rate is not so super high. So why would you do this? Well, battery temperatures have been modeled authentically in this jet, and that considers things like ambient temperatures and the charging rate, which are critical to the overall temperature of the battery. So if both of those are high, the battery will quickly overheat and be at risk of catching fire. So therefore, if you see a battery over-temp warning in the upfront annunciator panel, turn one generator off to reduce the rate of battery charging to reduce the battery temperature. This over-temp scenario can be caused by charging a depleted battery with both engine generators charging it. But also, the aircraft is modeled realistically enough to take into account ambient temperatures also. So don't be surprised when, as an example, you may see over-temps when sitting in a hot climate landing field with low charging rates when compared to not seeing anything if sitting in snowy Iceland with high temperature charging rates. But the takeaway is this: if you see battery over-temp warnings, reduce the main battery charging rate by turning one of the engine or APU generators off. There you have it. A healthy battery for a healthy aircraft. Later.